Alright, so what we're going to be doing today is we're going to solve quadratics by completing the square. So we're still in 11.1. And this is just an extension of what we did last time. So how did I know to use the square root property from last time? Who remembers? How do we know, kind of what are we looking for? What's the setup we're looking for to use the square root property? Close. It's a square on one side. So something squared equal to a number. We used our square root property. Well, what we're going to do today is we're just going to get every problem to look like that. So last time, and ours isn't filled in because of the computer problems, but last time we were solving things that looked like this. It had a binomial squared and it was equal to a number. So we had that nice binomial squared equal to a number. So what we're going to do today is we're just going to add a step that makes our problem look like this so we can go back to Monday and use our square root property. But we just have to do a little setup to get it to look like that first. And we actually did the setup part on Monday as well when we went through this section right here. So all we've got to do is put those two things together and we're going to solve problems by completing the square. Now, it looks kind of like, why would I go through all this work? This is actually a very practical process. I'll tell you, this is one of those things that, like, when I was taking mathematical finance, in the middle of problems, we would have to complete the square to be able to solve them. So this has more practical applications than some of the things that we do. Even though it looks like, why would I ever use this? This one comes up again more in math. And I also want to let you know, so I had to take my Praxis 2 math content yesterday. I had problems on there that asked me to divide rational expressions, which we did in 7.2. I had to work with the rules of exponents, rational exponents. I had to change the square root to a 1/2 power. And then I had to take the square root of y to the 15th. So if you plan on going on to getting those tests done, this stuff's on there. Some of the exact problems we do in here was on that test, which I found interesting. So alright, so it looks like there's a lot of steps for this. Most of it we've already done. We've already covered most of this. What we're going to do today is we're going to get our setup. So here's our setup. This is one of the big important parts. We're very, very big on setup in this section. We want the variable terms on the left side, so anything with an x on the left, and then constant on the right. And then we're going to use that little process from last time to fill in the blank. That little formula we had last time will fill in the blank, and then that left side will get factored. So we're going to end up with problems that look like last time, just got a little bit of setting up to do first. Anna. The blank here is going to be b over 2 squared. Yes. Yep. Same as last time. All right, so this is what your problem's going to look like. It's going to look like any of our other quadratics. And this is why it's really important in this unit to pay attention to directions. So this process is called completing the square. Completing the square. I have x squared plus 8x minus 1 equals 0. So what we're going to do is we're going to make it look like Monday's problems. So then we can use our square root property. So this first example I have kind of all the steps laid out for you, and then we'll do them without the writing. So our first check, there's two things you need for setup here. A has to equal 1, and you need the variable terms on the left, the constant on the right. So our first check, in this problem, does A equal 1? Yes, okay, so we're good. So we got that. Second check, do you have this format, ax squared plus bx equals c? So anything with an x on the left, the constant on the right. Where's our constant in this problem? What's c? 1. This is -1 right here. C is the number on the end. It's got to be on the other side. This is one of the few times where we move that number over. So when we solved by factoring, we wanted things equal to 0. When we solve using the quadratic formula on Friday, we'll want it equal to 0. But for the square root property and completing the square, we need the number on the other side. It's one of their key differences. So if I look at my problem, how am I going to move this -1 over? Just add 1. So if you're completing the square, we've got to move that number over. Now you'll notice that when I move that number over, I left myself in this problem space, a blank. But if I'm going to have a blank on one side, you need a blank on the other side. So we got to keep balance. Everything's got to happen on both sides. So now we've got to fill in the blank, which we also did on Monday. So ignore the right side. The right side doesn't contribute at all. So if I'm looking at x squared plus 8x plus blank, go back to Monday. We're going to fill in the blank using our little b over 2 squared. This was our little formula from Monday. So what's b? 8. So 8 over 2 is 4, and 4 squared, 16. Now we did that all in one step on Monday. We just wrote 8 over 2 squared and worked our way down, which is typically how we'll do it. But for this example, we're gonna spell everything out. So is everybody okay with where that 16 comes from? So that's Monday. So you take b, divide it by 2 square. It's just a formula. That's what you use. That doesn't change. So what that means is we're going to take our problem. Again, I bring it down. We're going to take our problem, and on either side, we're going to put in 16. Now, one of the most common mistakes in this section is to forget to add the 16 to the right, which is why I draw the blanks, so that you don't forget it goes on both sides. Some people also put boxes, like a box on both sides, just to make sure that 16 goes on both sides. We found it for the left side because we need it, which means we just have to add it to the right side to keep balance. Yeah?
That's always going to be the same number, 16 on that side, or whatever number you get on that side.
Yes, always, same on the other side, always the same. And it's always plus. That's another question I get a lot. It's always plus because of the squaring. So now, what else did we do with this x squared plus 8x plus 16 on Monday? Factor it. So when I factor it, that's going to be like the last step to get it to look like the problems from Monday. So I'm looking for two numbers. So we're going to factor the left and then combine the right. So factor the left, add the right. So the nice thing is, since we will always make sure a equals 1 before we start, you can always use the shortcut. This will always be the shortcut. So I'm looking for two numbers that multiply to 16, add to 8. 4 and 4. And they should always be the same. If they're not the same, you didn't complete the square. So my factors are x plus 4, or how else could I write that? X plus 4 squared. And then on the right side, you should always have two numbers, so you can add them together. 1 plus 16, 17. Now, hopefully that looks familiar. So we just did that on your drill. That was your homework. That was the notes on Monday. So we're just putting, again, those two concepts from Monday together. Because now I can use the process of, what's that other thing called? Square root property. Yeah, we're going to use the square root property. So the square root property is part of completing the square. Just got to get the whole setup for it. So I've got this quantity squared equal to a number. It's my setup for the square root property. What's the opposite of squaring? Square root. So I take the square root of both sides. This is Monday. And what else do I put on the right side when I take the square root of 17? Plus or minus. So on the left side, the square root and square root cancel. And I have x plus 4 equals plus or minus the square root of 17. Now what's my last step to solve for x? Subtract 4, and where do I put the minus 4 on the right side? Yeah, between the equal sign and the plus or minus. We make that sandwich. So whatever has the plus or minus, we always want it to come last. So So the last thing is always decide, do I need to go any further? And I had to put up, let's put our squares up on the board. So the square root of 17. Anything else for the square root of 17? No, 17's prime. It's not going to work. Oh, that's something else I have to do a lot. Or I had to do a lot, especially in the study material for the praxis, is simplify square roots. So we're going to put together those two concepts. You've got to get the setup first. A has to be 1. Split your variables in your number. And then we're going to use that little formula from Monday to fill in the blanks. Factor, like we did on Monday. Square root property, like we did on Monday. So most of it is just putting together other concepts we've already done. But when you get home and look at one of these problems, it's going to be that big old blank page. Very important in Unit 4. It's always important. Read the directions. Because all of the problems are going to look very similar. But there's 4 different methods that we have. Sarah? No. So there's going to be some questions where I ask for the method just so I make sure you can do all of them. And then others where it says just solve. And it's up to you. So I used to think that no one would ever pick this method to solve quadratics. But then once you get in the swing of it, the pattern's not bad, and some people really like it. The fail-safe method for every quadratic ever, quadratic formula. So I always say, because it's going to come up on your final exam as well, when in doubt, if it doesn't specify, always use the quadratic formula if you can't think of a better method. The only time I personally would elect to use completing the square is if after a equals 1, b is even. If b is odd, we did just one problem like that, factoring last time, and it became a mess. We had like 81 over 4 or something. So I'd only ever use this if I had a choice if b is even and a is 1. Which it's good to start picking out when to use the different methods. But yes, some of the time you'll have a choice. All right, so yeah. No, this is Friday. That's Friday. Learn the formula for Friday, and then Friday be like that, because it's plug and chug. We know how to find A, B, and C. You just throw them in the formula. All right, so we're going to, again, focus on the directions. This method is called completing the square. Setup. This is one of your extra credit questions. 2 things for setup. First, you can only do this if A equals 1. Does A equal 1 in this problem? Yes. Okay, so that setup's fine. Second setup criteria is it's got to be your variable terms. So that's anything with an x. That's what that means. Variable terms, x squared, equal to our constant. So before we dealt with a lot of equal to 0, but this time we want the constant on the right. Do I have that taken care of? Yes, okay, so we're good to go. Now, I always say think of completing the square as filling in the blank. Complete the square as fill in the blank. So I'm going to rewrite my problem with that extra room to fill in the blank. And that's the process from Monday. But if I put a blank on the left side of my equation, I've got to put a blank, the same blank, on the right side, just to keep that balance. So now we're going to fill in the blank. And we fill it in just focusing on the left side. What's my formula to complete the square? What's my formula to complete the square? What is it? That's part of it. B divided by 2 squared. So the formula for Monday is just b over 2 squared. So what's b in this problem? 6. The number in front of the y, so 6 over 2 squared. It's going to be 3 squared, 9. That's the number that fills in the blank. Whatever you get from that little formula, that fills in the blank. And what's the other thing after we filled in the blank? What's the other thing we did with the trinomial? We filled in the blank and then factored it. So fill in the blank, factor. Fill in the blank and then factor. So I want to factor y squared plus 6y plus 9. 3. So the number that multiplies to 9 adds to 6, 3 and 3. And we can write that nice, clean, condensed factorization by y plus 3 squared. That's why we filled in the blank. The whole reason we filled in the blank is so we could do that. What number is that going to be equal to? 1. You got to add the right side. So there should be 2 numbers there. And then once we have something squared equal to a number, what's that type of solving called? What are we using to solve that? Square root property. Square root property. Yeah, I'm just trying to associate names with processes, so when this comes up on your test, you know, completing the square is the filling in the blank, and then it comes down to the square root property, which is part of it and also a method by itself. It's part of completing the square and a method by itself. So how do I get rid of my squared? Square root. And what else do I put on the square root of the number? Plus or minus. So the left side, I lose the square root and the squared. That's why we did this process. So I give y plus 3 equals plus or minus 1. So perfect squares, I would just go ahead and simplify them. Square root of 1 is perfect, top of my list. So that's why it loses its square root, just because it's a perfect square. So it's harder to see maybe because it's the same number, but it's just because it's a perfect square. And now here's the question of the day. Because we had one like this. I had you guys try one like this last time. So I've got to move the positive 3 over by subtracting the 3. Should I combine it with the 1 right now? No. No matter what it is on the other side, it always goes before the plus or minus. So even though they're both numbers, you still put it before the plus or minus. We'll deal with that later. Whenever you move that term over, always in front of the plus or minus. Am I right a box? No, why not? Yeah, I've got to add and subtract those two because there's no more square roots, so I have like terms, which means I'll be able to combine them. So I'm going to go with negative 3 plus 1, and then negative 3 minus 1. So y equals negative 2 and a negative 4. Questions? Ask your questions on this one because then you're going to be doing it on your own. All right, solve the quadratic by completing the square. Completing the square is filling in the blank. First thing to look for in all of these problems, do you have your setup? And the setups are different for the different types of problems, so it's an important question to ask. For completing the square, do I have my setup? No. What part of the setup fails here? Yeah, a doesn't equal 1. I have to have a equal to 1. But in this problem, a is 2. How could I get rid of the 2 there? Yeah, just divide. Divide everything by 2. So that's going to give me x squared plus 4x. Now notice, I already have variable terms on the left, so I'm going to go ahead and leave myself room to fill in the blank. Equals negative 6, fill in the blank. So the second part is just to make sure it's your variable terms equal to your constant, which we already had that part taken care of. Really, it's C on the right and everything else on the left. So if you're solving problems and you want to say, would completing the square work well for this problem if the directions don't specify, if A is not 1, but it evenly divides everything, it's a good indication it might be an okay method. If after you divide everything by A, B is still even, that's when completing the square is not going to be too bad. It's if, like, this was 3 and this was 8 and 12, I wouldn't touch it, because then you're going to get 8/3 in the middle, and then you're going to have to divide that by 2 and square it, and, like, it just snowballs into bad. So A is 1, B is even, complete the square, otherwise quadratic formula. All right, let's fill in that blank. Someone got a number for me? I see y'all crunching. You missed a step. What do you have to do with B before you square it? Divide it. Yeah, so my formula, we're going to have several formulas in this unit. Yeah, keep them straight. B over 2 squared. So I'm going to take the 4 over 2 and square it, which is just 2 squared, which gives me 4. So my blanks are getting a 4. Both blanks, 2 blanks, or 2 boxes, or 2 circles, or 2 triangles, whatever you want to put on both sides. And then we're still focusing on the left side. After we filled in the blank, what did we do with the trinomial? Factored it. So we fill in the blank so we can factor it. So I'm looking for a pair that multiplies to 4, adds to 4. 2 and 2. And remember, it also is always this number right here. Whatever number you squared in the end, it's always that number in your factor, which is what you needed to realize today for your drill when I gave you like the x squared plus 7x or something like that, where it didn't work out so nicely. So we're looking at x plus 2 squared equals negative 2. And then what's this method called? At this point, something squared equal to a number. Square root property. Square root property. So to get rid of the square, we take the square root of both sides. And on the right side, you always put in a plus or minus. Square root of negative 2. Square root and square root cancel on the left. So I have x plus 2 equals plus or minus the square root of negative 2. You can either simplify the square root now or you can simplify it at the end. If it's not perfect, I usually do it last. It does not matter. I'm going to finish solving for x by bringing this plus 2 over minus 2 in front of my plus or minus. Because if you get this far, you'll get most of the credit. You've solved for x. You've just got to simplify for full credit. Careful, the I never goes underneath. I square root of 2, yeah. So it's going to have the imaginary unit because the negative's underneath. So if you're splitting it up, you take a negative 1 times 2 under the square root, and the I always comes out front. Yeah, I is always out front. It comes from this square root of negative 1. So it's negative 2 plus or minus I square root of 2. Yes, if you have the square root of a negative, just put your I out front of the square root, and then the radicand becomes positive. And again, don't try to like fling that I over with the first 2. It stays with its square root buddy after the plus or minus. Can I put those 2 together? No, because that would be a mess. One's a constant, one's not only a square root, but also imaginary. Those aren't like terms. You can leave them stacked, or if you like to see your 2 answers, you can separate them, but you don't have to. Questions? All right, I think we got one left, right? That's you guys. All right, try D. All right, so that went pretty well. A few little things, nothing we can't correct. But if you don't do this again before Friday, I can tell you what, when I give you your drill is 1, maybe 2 questions, just because it's a little bit longer process. So you got to be solid on these steps. First question, do I have my setup all taken care of? Is this set up to complete the square? No. What do I have to fix? Can I get a little... Thank you. I know it's very exciting, completing the square. So we're going to subtract 1. So we got to take care of that setup. Leave room to fill in the blank. Complete the square, fill in the blank. Make sure you use the -1. So that was the first thing I saw on several people. It's not just one person. Several people had a +1 on the right side. Use the opposite side. And how do I fill in my blank? We use the formula. B over 2 squared. So I'm going to just take -10 over 2 squared, which is -5 squared. And be careful, whenever you square a number in one of these problems, it always turns positive. -5 times -5 is positive. So I had people who used their calculator and their head and still got -25. Always positive. This answer here from our formula in this problem is always positive. And it's good I saw everyone put it on both sides. That's another very common mistake, is to leave it on only one side. And then why did we create this perfect square trinomial on the left? What do we want to do with the left side? Factor. Because we don't want to forget factoring. Unit 1, we loved factoring. So a pair that multiplies to 25 adds to -10. It will always be this number right here. When in doubt, it is always that number. It's x minus 5 squared. So the factoring process shouldn't be hard on these. It's always this number. And it's equal to 24. -1 plus 25. And then I saw everybody using their square root property, which was to get rid of that squared, we take the square root. On the right side, don't forget the plus or minus, the other most missed thing on this question. And I will tell you, in the past, completing the square was always a final exam question. I don't know, they changed it again this year, so I'm not sure what's on there, but. So I have plus or minus the square root of 24. I always solve first, so I at least know I have an answer for x in case I can't get the simplifying. So I have 5 plus or minus the square root of 24. Square root of 24, can I simplify it? What's my product for 24? 4 and 6. Now this is another thing that I saw in your test as well. It's not just 4 times 6. It's the square root of 4 times 6. So make sure that you've got in your mind that it's the square root, because when I simplify, I don't have 4 anymore. I have the square root of 4, which is 2 square root of 6. So x equals 5 plus or minus 2 square root of 6. All right, put them together. Keep going. Doesn't have a square root. That's it. We're done. Yeah, because if you think you can combine them, my suggestion is that you always expand it first. So if you expand it, you say 5 plus 2 square root of 6, 5 minus 2 square root of 6. And I think it's a little bit clearer, 5 and 2 square root of 6 aren't like terms. And 5 and minus 2 square root of 6 aren't like terms. So, nope, that's where you'd cut it off.